Hello, thank you for joining RasPipKr tutorials. I'm Martin Parker, and in this Python tutorial I'm going to talk to you about binary, hexadecimal and octal. It is part of your standard library, so there's nothing to install. As you may notice, I've tidied up my desktop by sticking everything in a sort of later folder, and I've also changed the background, just looks a little bit more mellow. So if we want to find out the information, the documentation, it doesn't really tell you much, but in the help, and you pass in bin for the binary function, built-in function, it will give you a little bit of information. So basically, when you pass it bin, and then in parentheses brackets a number, you'll be returned with a string representation of a binary number. And the first two characters will be 0 and a lowercase b to represent that it is a binary, and all the numbers that are after there are the actual binary number for the number that you passed in as an argument. The way that binary works is its representation either as a 1 or a 0. It works in that you could use it as a true or false. Basically, you work from the right hand side to the left, and it works where it doubles. So this would be 1, this would be 2, this would be 4, this would be 8, this would be 16, and so on. So let's just enter bin 10 to get the binary of 10. Go away, thank you, silly box. So we've got our return string with a 0b for our binary number, and there is the number in that it's returned of. So we do not have a 1, but we do have a 2. We do not have a 4, but we do have an 8. So 8 plus 2 equals 10. So that's pretty much binary. And you can do it in the reverse if you wish to find out the number that it is working with. So if you pass in integer, and then if you do the same as what we've done, well, we see above, if we do the 0b to tell it that we're working with a binary, and we pass in 1010, it's going to return with the integer number rather than it work from the binary. Let's move on to hexadecimal. So if I put in hex, it will give you some very little information, but basically it is a hexadecimal representation of an integer. So when you pass hex, notice how it changes colour just like the bin, because it's a built-in function. Pass in a number into the parentheses brackets, and it will return a string with a 0x to represent that it is a hexadecimal, and then a series of numbers or letters after to represent the number that was passed into it. So if we do 10, just like we did with the binary, it's come back with a 0x as that it's a hexadecimal, and the A represents 10. So let's see if it does it in reverse, just like, nope, it's come back as that, because even though we could do it there, I shouldn't have done it as A, that's my silly mistake. I should have done it as 0x A, and then we get the integer of the hexadecimal. So it works both ways. Just make sure you do put the 0x, unlike my silly mistake there. So let's have a look at the oct for octal. Same sort of thing. It's a built-in function. It's an octal representation of an integer. So when you pass oct, it does change colour because it's a built-in function, and in your parentheses brackets enter an integer number, and it will return a string of 0a, these are lower cases, to represent that it's a octal number. and it'll return a number after there where it runs up to the number of 8, and I'll show you some examples now. So if I do octal of 10, you can see that I've got a 0 and an O to represent that it's an octal number, and then a 12 after. I'm going to create a little test function here. It's going to pass in a number as a range that I'm going to work in a for loop, and it's going to pass in another argument called func, because we're all funky. Basically this is going to be a for loop, so for I in range, and we're going to pass in the num, but we're going to plus 1 so that it will do the number that you pass in as well as. And it's going to print to the screen, and it's going to be, shall I put it as I or the number? We'll go with the number is, and we'll pass in there, and we'll go with that, and we'll do the dot format so that we can pass in as a placeholder into this placeholder, sorry, the number of what we're working with. So we'll pass in I, in this placeholder here we will put in the func that we're working with of I, and close off that format function, and then close off the print statement. I should have imported time beforehand, but it will let me do it because I'm in a function that I'm making. So I'm going to put time.sleep, and it's going to sleep for 1 second, and that's the function done. And if I import time now so that I don't get any errors, let's run our function. So if I do test, and we'll go for 10, so like here we did the binary, well it's up here now, of 10. Let's create binary numbers up to 10, and we'll use the bin function, and if I press enter it will give out the numbers with a second gap in between. So this is how you can do some binary work, rather than the time.sleep. It would do it obviously quicker, but you could get it to print just that number that you are passing in. So let's do our test function again, but this time I'll do 10, but this time we'll do the hex function, and there again it's going to give us our hex numbering, like so. And notice how it brought an A into it. Should have done more than 10 really. Let's go for 25. Whoops. Hex. So it's just going to take 25 seconds, but you'll see how it works out. So notice there it starts with a 0, x, and then the numbering. So we're starting with zeros and we're going up to 9. It doesn't do 10, but it does an A, so it goes up to, it does 16 because 0 is the first one, and then it starts with 1, 0, and then it will go through the numbers again, and then it will do the letters. So that the 26 would be 1A. So let's do our test function again, and rather than doing it to 10 first of all, I'll just do it straight to 25, and this time I'm going to use the octal. So there we go, octal 0, O, and it's starting with a 0 and it's going up to 7 because it's giving you as 8 numbers. There you go, highlighted the right one this time. So it's going up in 8s, like so there, and there again, and then it's starting again on the next following 10s value. We didn't do up to 25 as binary, so let us just do the 25 with the binary. So there you go. A quick overview on how you can use the oct, hex and bin as part of your, well, in fact int as well, because you can reverse it like I did earlier. So there we go, some binary numbers for you up to 25. Okay, thank you for watching, and I will catch you in the next one.